So today we're going to pull it all together. We're going to take everything we know about parallel lines and we're going to write proofs. So proofs are just a way of thinking, and we do this all the time. Every time we're in class and I say, what do you know and why do you know it? We're going to write two-column proofs, and we're just going to detail out what we know and why we know it. Okay, so our statement, so a two-column proof looks like this. The statement side is what we know, and the reason is the why we know it. So the first statement in a two-column proof is always the information that you were given. That means this is what you know. It's all you know. You cannot assume anything. You can't presume to know anything. You only know what you have been given and then what you can deduct from there. The last statement is always going to be what you're trying to prove. Okay, there are a couple properties that you need to know. The substitution property says that if A is equal to B, then A can replace B in any equation. Okay, that is just substitution. Now, a special version of the substitution property, which is really what we're going to use, is the transitive property. The transitive property says this, that if A is equal to B, and B is equal to C, then what I know, what has to happen is that A must equal C. What we're doing is we're taking out this middleman. Why do we even need him? If A is equal to B and B is equal to C, why do I even need B? I can just go straight to saying that A is equal to C. So let's look at some problems. And so here's what I recommend that you do. I always recommend that you highlight and you mark the picture to show what you know. So I know that G is parallel to H. That's what this means right here. And then I know that 1 is congruent to 2. That was given information. 1 is congruent to 2. Now, what I am trying to prove, I'm trying to prove that P is parallel to R. I don't know that it is. I know that it looks like it, but I don't know that it is. So I want to start working my way around this shape. And we do this, we're going to just start with fill in the blank proofs. And as we go through the year, you'll get better at these. But the first thing I know is that G is parallel to H and 1 is congruent to 2. And I know that because it's given. That will always be the first thing that you know. Now, based off of that, I can look at this picture, and if I give you this information, if I tell you that two lines are parallel, you will always use that in the form of alternate interior, alternate exterior, corresponding, or same side interior. Okay, that's why we studied those. So angle 1 is congruent to angle 3. Why do I know that? Because those lines are parallel, and those angles are congruent angles. Now, other thing, I didn't mark it, but I should have. What I'm trying to prove is that P is parallel to R. That's what I'm trying to prove, and I'm just going to mark it so that I don't forget. That's where I'm trying to go. So I know that because G is parallel to H, if lines are parallel, then I know that corresponding angles have to be congruent. That was one of the first theorems that we talked about, that if those lines are parallel, that must mean that 1 is congruent to 3. So my next step is, why can I say that 2 is congruent to 3? Now, you're going to be tempted to say because P is parallel to R. But remember, that's what we're trying to prove. You don't know that yet. But look right here. Notice that I have 1 is congruent to 2 right here, and 1 is congruent to 3 right here. Well, if that's true, then what do I even need the 1 for? I can skip straight to saying that 2 is congruent to 3. That's that transitive property. I'm going to pull out that middleman. I don't even need him. Then, now that I know that 2 is congruent to 3, now I can say that those lines are parallel, because we just learned yesterday if corresponding angles are congruent. No, I'm shorthanding and I've lost my place. If corresponding angles are congruent, then lines are parallel. And it does matter which order you write these in. Up here at step 2, I knew the lines were parallel, so I can talk about the angles. In step 4, I knew about the angles, so I could talk about the lines that were parallel. So what comes first is the part that you know. What comes next is is the conclusion that you're going to make. So we just proved that P must be parallel to R. So let's look at the next one. L is parallel to N. So I'm going to label that. L is parallel to N. So we always write that first. L is parallel to N, and I know that because it was given. So based on that, now I've given you a hint. There are lots of things that I can say if L is parallel to N because I know all about the alternate interior, alternate exterior, all those angles, but I'm giving you direction. I want you to start with angle 2 is congruent to angle 8. Okay, now if the lines are parallel, remember I always told you if I give you that lines are parallel, it's always going to result in your next statement being one of those 4 pairs of angles. So angle 2 is congruent to 8 because if lines are parallel, which I said they were, then I'm allowed to talk about the alternate exterior angles being congruent because the lines were parallel first. Now, from there, remember, I'm trying to get to angle 2 and angle 7 are 180. So I'm trying to get to angle 2 and angle 7 equal 180. Well, I don't have any reason to know that, so I've got to prove something else. So if I look, angle 8 plus angle 7 is 180. Why do I know that? Well, I know that those are a linear pair. So that is a definition of linear pair. Now, because of that, if you look at that next hint that I gave you, we want to use substitution. So what do? So substitution, well, I know that if 2 is 8, can't I just replace this 8 with that 2? And then I can say that angle 2, or the measure of angle 2, plus the measure of angle 7 equals to 180 because I just replaced that 8 right here in this equation with that 2 using the substitution property. So we've just proved that those 2 angles are supplementary using stuff that we know. That's the point of proofs, is to start with something we know and then to find out things that we don't know. We always want to learn more about other things. Okay, so let's start here. If J is parallel to K, and if K is parallel to L, I want to prove that angle 1 is congruent to angle 3. I want to prove that angle 1 is congruent to angle 3, but I don't know that yet. So I need to start with what I do know. I do know that J is parallel to K and that K is parallel to L. And I know that because I told you so. It was given. So the next hint that I've given you is I want to start with angle 1 is congruent to angle 2. So I know that angle 1 is congruent to angle 2. And I know that because if these lines are parallel, then I know something about the angles. So if lines are parallel, then corresponding angles are congruent. So I know that 1 is congruent to 2. Now, look at the next hint. I want you to use that same again. If lines are parallel, corresponding angles are congruent. Well, let's look. Okay, I know that K is parallel to L. Okay, I've got K is parallel to L. Well, that tells me that angle 2 must be congruent to angle 3 because this is parallel to this. K is parallel to L. Because if those are corresponding angles and if those lines are parallel, then those corresponding angles have to be congruent. So now I want to get to the end. Well, I notice that if angle 1 is congruent to angle 2 and 2 is congruent to 3, I can pull out that middleman and say 1 is congruent to 3 because of the transitive property. Last one. Angle 8 is supplementary. Remember, that means that they add to 180 to 3. So angle 8 is supplementary to angle 3. Now, I have no reason, there's no rule that says that. I'm just telling you that they are. And that's always the first thing that I say. Angle 8 is supplementary to angle 3. I'm just shorthanding it a little bit because I was given that information. I was told that. That's how I know. I was told. Now, in geometry, we have to be very distinct, right? We said supplementary means it equals to 180. So because I know that it's supplementary, because of this statement right here, I can say that it equals 180. So that needs to be the next thing that I say. That's because that is what supplementary means. So we would say the definition of supplementary. Supplementary means that two angles add to 180 degrees. Now, remember where I'm trying to get to. I'm trying to get to L being parallel to N. I don't know that yet, and I won't know it until the very end, but I'm trying to work my way around it. So the hint that I gave you is that 8 plus 7 is supplementary. So you look up there at 8 plus 7, and you see why is it supplementary, or why does it equal 180? Well, we know that because they are a linear pair, and the definition of linear pair says that. Okay, from there, I gave you a hint to use the transitive property. So that means you should look for a middleman. Well, I noticed that this statement here has an equal to 180, and this statement here has an equal to 180. So I can take out that middleman and say that angle 8 plus angle 3 is equal to angle 8 plus angle 7. That's what the transitive property lets me do, is it lets me pull out that middleman. Okay, now I want to use subtraction. Okay, I want to use subtraction to get to the next step. So what I notice is that there is an 8 on both sides. Angle 8 is on both sides. So if I subtract angle 8 from both sides, it leaves me with angle 3 is equal to angle 7. So I used subtraction to get from 4 to step 5. I just subtracted 8 from both sides. So subtracting angle 8 resulted in angle 3 is congruent to angle 7. So now let's look. If I've got angle 3 right here is congruent to angle 7, what I notice is that those are corresponding angles. And if corresponding angles, what we just learned is if corresponding angles are congruent, then lines must be parallel. So now I can say that L is parallel to N because if the angles, remember I knew the angles, it resulted in the lines parallel. If corresponding angles are congruent, then lines are parallel. Now, there are lots of ways that you can write proofs. There's lots of information that we knew. We just want to be manipulative about the material that we want to use so that we can prove what we're trying to prove. And in this case, we gave you fill in the blanks so that we could kind of guide the direction that you wanted to go in as you learn how to do these. So remember that you always start with the given information, and your last statement is going to be what you're trying to prove, and you have to use different reasons that we've learned to be able to prove that